So it's my great pleasure to introduce the research presentation every board meeting. And today joining us is Dr. Honglei Chen. Dr. Chen is an MSU Foundation Professor of Epidemiology and Biostatistics in the College of Human Medicine. He came to the U.S. in 1996 as an international student from China, earned his Ph.D. in Nutritional Epidemiology at Tufts University in 2001. He then postdoced at Harvard University for several years, and then took his first position at the National Institute of Environmental Health Sciences, and he led the Aging and Neuroepidemiology group at the NIEHS intramural grant program. Dr. Chen joined MSU in 2016 as part of the Global Impact Initiative. He studies the development of Parkinson's disease and dementia with the ultimate goal of prevention and healthy aging. More recently, he has focused his research on understanding how poor sense of smell is a predictive symptom for neurodegeneration and is a marker of accelerated aging. Dr. Chen has published more than 200 papers in mainstream health journals such as the Annals of Internal Medicine, Annals of Neurology, Movement Disorders, and Environmental Health Perspectives. Dr. Chen's research at MSU has been generally supported by the NIH, DoD, Parkinson's Foundation, the MSU Foundation, and the Gibby versus Parkey Project. So please let me bring up Dr. Chen. Thank you.
Good morning. Thank you, Dr. Gage, for your kind introduction, and also thank the board for the opportunity to speak. Today, I'm going to talk about the sense of smell, and I'm going to talk about the sense of smell and health in older adults. First, let me ask you this question. How is your sense of smell? So if you don't know it, you surely are not alone. Because unlike vision or hearing, we pay very little attention to our sense of smell. We just take it for granted. And in fact, most of the people with a poor sense of smell may not realize they have it. But that's important. Let's take a look at the numbers. So these are the data we published about 4 years ago, looking at how common is anosmia, the total loss of the sense of smell in older adults 65 years or older. And we found out about 15%, 14% of the older adults have anosmia, total loss of their sense of smell. And I hope I can point to it. The prevalence increased dramatically with age, and also is about twice more common in men than in women, and in African Americans than in white Americans. And when we talk about the group of very old, 85 years or older, we are talking about 60% of African American men have anosmia, total loss of sense of smell. This is not just a decrease in the sense of smell. And about 55% of black women. So the numbers are huge, but again, doesn't matter. So we learned this primarily from the research on neurodegenerative diseases like Parkinson's and dementia. These are the data we published again 4 years ago. Compared to older adults with good olfaction, these are the good sense of smell, normal sense of smell. Those with poor sense of smell are 5 times more likely to develop Parkinson's disease and 3 times more likely to develop dementia. In the eyes of epidemiologists, these are very strong associations. And more importantly, these are not just like phenotypical associations. These actually have a pathological underpin. So this is the hypothesis proposed by Brack about 20 years ago based on examinations of hundreds of brains of Parkinson's disease patients and controls. And he found out and proposed that the pathology of Parkinson's may start in the olfactory bulb. The tiny little structure deliver our very important in the delivery of our sense of smell. He proposed that the pathology start in the olfactory bulb right here, years, if not decades, before the clinical symptoms of Parkinson's even developed. So this suggests that the poor olfaction, poor sense of smell, is an early, very early preclinical symptom of Parkinson's disease. And actually, it is an integral part of the disease natural history. It's simply part of the disease. Why this is important? We know that the olfactory pathway is at the interface right between the environment and our brain, and thus it provides an unprecedented opportunity to understand the role of environment in neurodegeneration, in Parkinson's and in Alzheimer's disease and dementia. And I'm going to tell you more details about this. So as Dr. Gage introduced, I spent about 20 years studying the epidemiology, the environmental risk factors for Parkinson's disease. And we know that Parkinson's disease typically diagnosed around age 65, 70, 75. But in the past 30 years or 20 years, we also know that the disease actually takes decades to develop. But unfortunately, until very recently, the prodromal stage, the decades-long prodromal or preclinical stage of Parkinson's, remain a black box to us. As a result, our research on the environmental or non-genetic risk factors for Parkinson's disease is more like the story of blind man and the elephant. It's our hope that by better understanding the intermediate symptoms like olfactory impairment and other preclinical symptoms, together with the study of subtle motor signs and subtle mild cognitive signs, we will be able to better understand the etiology of dementia and Parkinson's disease. This will bring a higher resolution to the black box, decades-long prodromal development of the disease. So we can study the factors that actually can trigger the disease etiology, and also the factors that can modify its progression to its clinical phenotype. So this is our hope. And I have two federal support to research into these questions. But the story about the sense of smell does not stop here. This is the data we published about 2 years ago that poor olfaction strongly predicts the risk of death in older adults. Compared to older adults with good olfaction, those with poor olfaction were 50 more likely to die in the next 10 years. Considering the death is ultimate health outcome for any organism, this number is very important. Interestingly, Parkinson's, dementia, the ones that we know strongly associated with poor olfaction, only explain about 22% of this increased the excess mortality among people with poor olfaction. Adding another 6% introduced by the weight loss, still over 70% of the excess mortality among those with poor sense of smell remain unknown. So what are the missing links? Above and beyond Parkinson's and dementia, we actually have very little evidence about the other potential health connections relating poor olfaction to adverse health outcomes. But there are quite a number of speculations, hypotheses. For example, poor olfaction may lead to change in diet, lifestyle, and metabolism, and may expose people with poor sense of smell to the bad, harmful environment. And over time, this may lead to malnutrition, weight loss, depression, a long list of chronic diseases, and also functional decline and frailty, which are not trivial in older adults. Eventually, this may contribute to the increased mortality. So this led me to think about my third project, which I'm thinking about above and beyond neurodegenerative diseases. What other conditions in the elderly could be a consequence of poor olfaction in older adults? In other words, can putrefaction be a miner's canary for age-related health issues besides neurodegenerative diseases? For example, this is related to higher risk of heart disease, lung disease, and metabolic diseases. Along this way, we published a paper early this year showing that putrefaction is associated with higher risk of pneumonia in old adults. This is not the COVID-19 pneumonia. This is, the pneumonia we used to know. And could it be associated with functional decline and frailty, faster functional decline? Along this way, we also published a paper. The first longitudinal study showed that putrefaction predicts faster physical functional decline. And also because the sense of smell only take a few minutes to test in the clinic, and it's non-invasive, I'm also very interested, could it be actually be tested as a non-invasive marker of age acceleration, and will that be of any clinical use? So these are the questions I'm very interested in testing. And I see this as an unexplored opportunity to inform the broad need to assess olfaction in the older adults to better understand their health changes and to anticipate any risk of impending conditions. So if somebody asks you again about this question, I hope you will be answer, yes, I do, and I hope you as well. And finally, I would like to thank my collaborators and also my funding agencies, including NIEHS, DOD, Parkinson's Foundation, the Gibby versus Parky Foundation, and also MSU internal sources. Thank you, and I'm open to questions.
Does anybody have any questions? So I have a couple. They'll be quick, I promise. First is, you mentioned your ability to use a lack of olfactory ability to maybe be a predictor. How do you actually quantify lack of olfaction? What's actually the test you use to be able to compare people?
It's amazingly easy. There are several commercial tests. It only takes 5 minutes. Typically, people use the identification test, but of course, there are threshold and the discrimination and other tests as well. But the most commonly identification test, you basically just presented 12 different odors. You try to smell it and identify the correct odor out of 4 possible answers for each. So you got a score 0 to 12, and based on the score distribution, you can it's remarkably consistent.
Got it. That's very helpful. And another question was, you mentioned at the beginning that there's a huge disparity between blacks and whites in developing loss of olfactory ability. Does that correlate then with different rates of Parkinson's disease in those two populations?
It's very interesting, actually. It's much more prevalent in African Americans. But when we analyze the data are very preliminary. I have to say that, we found that the association with neurodegenerative diseases is stronger in white than in black. So leading me to think that, whatever leading to the process of smell may be different in these populations, and what the consequences of the process of smell may be different by race. And that's something I'm very interested in understanding.
Got it. Thank you so much. Any other questions?
Can I ask one quick one?
Of course.
I'm curious, I think their data studies were like 2019 was the most recent data set that you talked about. And so how has COVID-19 and how will it impact you? Because my understanding is that one of the side effects for some people is a loss of sense of smell. And does that impact your future data sets and your ability to research? And how do you account for that?
That's really good question. Just for the information, the loss of the sense of smell is presenting symptom of COVID-19 infection. And we are actually collecting data during this period. We are very concerned about that. So, in one study, we collected data right during the COVID-19, and we are going to do a stage 2, which is post the COVID-19. And before the COVID-19, we only have the self-reported. So we are going to be able to analyze and evaluate whether there is any changes in the test, not only in the test, how people recognize their sense of smell by analyzing the self-report data. So the data are yet to see, and I hope no matter what, after the COVID-19, people will pay more attention to this, common deficit, sensory deficit.
Thank you so much for your presentation, your work, your contribution to the academic reputation of MSU. I do have a question. There's some slides back though. Can you go back to that slide where it had coffee?
Oh.
Yeah, right? No, go, yes. So you didn't really explain what's happening right here, because I think some of these things I do, and I think I'm in that midline. So right.
Okay, so my intention here is only to demonstrate that our past research on the etiology, which are the risk factors for Parkinson's, in my own research, is almost clueless, because we do not understand how the disease starts, how the disease develops, what factors involved. I put over all this because I publish on almost everything in relation to Parkinson's diagnosis at age 70. Can you imagine somebody to study coffee drinking in the 20s and Parkinson's disease in the 70s and leave the 50 years in between not accounted for? We were able to publish, but what does that mean?
Right. So we don't know.
Yeah, I'm talking about, we are doing the blendment and everything. So no worry about the coffee.
It's inconclusive is what you're saying. We don't know.
And by the way, the data suggest, I think, the association is fairly well established that coffee drinking was associated with a lower risk of Parkinson's disease. Although the mechanism is still under, investigation.
Because I was confused by like what's not good, what is good. So thank you for that. And then the other question I have is, what kind of students are you engaging in this research? Because the pervasive inequities around medical, I think this is really important, around age and race and gender and even environment. And for our students, particularly our students who are interested in STEM, to be engaged in this kind of research is so important. Do you have any students? Can you get some students engaged?
Yeah, I have. I was really fortunate in my first few years at MSU, to work with very hardworking and brilliant, PhD students. And my students at this moment are primarily PhD students, but I hope that I will be able to engage more undergraduates and also master students, a diverse group, into my study group to look into these issues. Because, I probably understand the science, but there are a lot of other things I do not understand, and I want to learn from them.
Thank you so much.
Any other questions? This has been a great discussion.
Fascinating.
Okay, thank you.
Yeah, Dr. Chen, thank you.